Okay, hello everybody. So today we will begin our discussion in Chapter 8, Section 5. And what Chapter 8, Section 5 begins to introduce to us is the concept of a GCF with polynomials and how we end up using that. And what we end up doing with the GCF of polynomials is we end up reversing what we've been doing in the last few sections. So in the last few sections, we have been learning to multiply polynomial expressions together and then combine the like terms so they're in the most simplified form, which we call standard form. Moving forward, we are going to learn to basically undo what we've been doing. We're going to undo that multiplying and combining things. And in order to undo things, we need to discuss what it means to be a GCF of a polynomial. So let's start with just a quick review of what a GCF is. A GCF is called the greatest common factor. And recall that a factor is a number, or in this case, you'll soon see variables that will divide into the original number or expression that you have. So you can see I have two numbers here, 6 and 15. We want to come up with the number, the biggest number, because it's saying greatest number that will divide into both of those. Now, the old school probably way that you were taught, I don't know, a couple, 2, 3, 4 years ago, was to list both of the numbers and then write out all of the factors. So in this case, for 6, we would have everything is divisible by 1, so you always start with 1. And then you have 2, 3, and 6. And now for 15, we're going to write out the factors. What numbers will divide into 15? I always like to start with the lowest and work my way up. Just go through the numbers in your head. Will 1 go in? Yep, 1 always goes into a number. Will 2 go in? Nope. Will 3? Yes, it will. 4? No. 5? Yep. And you can see 3 and 5 are pairs, right? So once you have 3 and 5, you aren't going to have any more other than the number that pairs with 1, which is, in this case, 15. And so there you go. We have all the factors written out of 6. 6 is 1, 2, 3, and 6. 15 is 1, 3, 5, and 15. And what they want is the greatest common. So the reason why they say the greatest is they want the biggest number. And when they say common, common means it's the number that they both have. Now, in this case, these two numbers only share one common factor. And so it's going to be the greatest. And that number is 3. So there's your answer. The GCF is 3. So we have a few more numbers to take a look at. Now, once again, you can write these. I'm going to show you a little different way to do this now when you write out factors. We'll start with 12. Another way that I like to do this is instead of going from least to greatest, I like to write them as pairs because it kind of helps you know when you're done. So we'll start with 12. We know 1 will go in and 12 is paired with 1 because 1 times 12 is 12. The next smallest number that will go into 12 is 2. Now we have to figure out what number is paired with 2 that will go into 12. 2 times what is 12? And we would say 6. Okay, so now so far we've gotten 4 factors. Keep going. Is 3? Will 3 go into 12? Yes, it will. 3 will go into 12. 3 times what is 12? 3 times 4 is 12. Now you can see, because there's no more numbers, we've covered them all. We went 1 and got 12. We did 2. We got 6. We got 3. And then we got 4 that goes along with that. There's no more numbers in between 3 and 4. So we are done. So we have all 6 factors of 12. Now we're going to do the same thing for 30. We'll start with 1, pair it with 30. Then we'll go to 2. 2 times 15 is 30. Then we'll go to 3. 3 times 10 is 30. Now we'll try 4. Does 4 divide into 30? Well, 4 times 7 is 28, and 4 times 8 is 32. So 4 will not go into 30 evenly. So we move on to 5. Will 5 go into 30? Yes, it will. 5 times what is 30? Well, 5 times 6 is 30. So now that we have 5 and 6, there's no more numbers in between there. We're done. We found all the common factors. We found all the factors. Now the goal is to find common factors and find the biggest one. You can see that they share 1, they share 2, They share 3. They also share 6. Which one is the biggest? Well, I think that's pretty obvious. It's 6. So that means 6 is the GCF. So this is the other way that I like to find GCFs. I think it's a little bit better because you have less of a risk of skipping over a number as you're trying to figure out all the numbers that will divide into what you were given. So we're going to do that the same way with 24. Start with 24. You'll see I go through 1 and 24. 2 will go into 24 since it's even. 2 times 12 is 24. We have to determine whether 3 will go in, and it will. 3 times 8. Then we go to 4. Will 4 go in? Yep. 4 times 6. So now you can see we have this pair, 4 times 6. So the only other number that we haven't tried yet is 5, because there is a 5 in between 4 and 6. 5 will not go into 24 evenly. 5 goes to 20, and then it goes to 25. So we're done. We found all the we found all the factors of 24. We will do the same thing with 40. 1 and 40. 2 and 20. 3 will not go into 40. 3 times, 3 times 13 would be 39, and 3 times 4 would be 42. So 3 times 14 would be 42. So it will not go in. 4 will, though. 4 times 10 is 40. 5 will, because it ends in a 0. 5 times 8. So then we have a few numbers between 5 and 8. We have 6 and 7. So we try 6. Will 6 go into 40? It will not. If you count by 6s or think of your 6 times tables, 6 times 6 is 36. 6 times 7 is 42. So 6 will not go into 40. 7 is going to give you the same result. 7 times, 5 is 35. And then 7 times 6 is 42. So you will not get 7 to go in evenly. So now we know we're done for the factors of there. So let's go back and identify all the common factors. They both have 1 as a factor. They both have 2 as a factor. They both have 4 as a factor. And they both have 8 as a factor. And so if I ask you to pick the greatest common factor, the answer will be 8. So the GCF is 8. All right, now we're moving on to greatest common factors of algebraic expressions. Now, this is a little trickier because we're not dealing with numbers, we're dealing with variables. And you'll kind of catch on to this, but to start this off, I'm going to show you a very visual way to do this so it makes sense. So what you want to do is you want to take each of the expressions that you have and you want to expand those out. So when I have x squared, what does that mean? Well, x squared means x times x, right? Now, if I look over here, the other expression is x to the 5th. Well, what does that mean? Well, that means x times x times x times x times x. So that means there's 5 x's. So what you want to do now in these two separate expressions is to take the most amount of each of the expanded expressions, the most amount of each variable of the expanded expressions. So what do I mean? Well, this has 2 x's, so we're going to bring both of those down. This has more than 2 x's, but we can only use 2 of them because we're capped out at this one only having 2. So what is the GCF? Well, they both have 2 x's that we can take. And so this becomes x squared. And that is your GCF. So again, kind of to recap, the GCF is the most amount of variable that both of the expressions have. So this one might be a little bit easier to understand when I expand this one out. So when we expand r squared times t, you get r times t. Now when I expand r times t to the third, I get r times t times t times t. So again, we need to pick the most amount of variable that both expressions have. So you can see over here, this one has two r's, but this one only has one r. So what we have to do is we will only be able to list one r. Okay. Now this one has one t, this one has three t's, but we cannot list all three t's. We can only take the most amount that they both have. They both have at least one t, so I will write one t right there. And that RT is the GCF. Okay, so I hope that made sense. I will do another video, which is going to continue finding greatest common factors and expressions that you see there. But in the meantime, if you have any questions, feel free to email me. Have a great day.